Hello and welcome to the Java and Minecraft modding tutorial. Today we're going to go over inheritance. First thing I want to do though is teach you a little thing about Java called packages because it's probably pretty useful. Notice here how this says default package. Default package is basically the package which your program is assumed to be in, and it's a funky way of saying no package. Default package just means that there's no package, and you can make packages, and it's used for organizing programs, organizing different classes in a program, and it can also be used to indicate multiple classes with the same name. For example, you can create a class called scanner because it's in your program's package. Even though there already exists an existing scanner class in Java, you can create a new one as long as it's in a different package than the original one. Seeing as the original one is somewhere in this JRE system library, you don't really have to worry about creating a new package. Look, this is a package. This is technically not a package. This is a library, but this is a package, java.awt.datatransfer. A package, the dots separate different sub-packages. So java.awt.datatransfer is the data transfer package inside of the AWT package inside of the Java package. Kind of like how writing a class name and then dot and then a field name indicates the field inside of a class. Now, we're going to organize our program into a couple of packages. We don't have a lot because we don't have a lot of classes in our program, but that's going to change. But anyway, what you can do is click New Package. Then I'm going to name this one Animals because we have an animal class here, and we're going to put inside of the Animals package. And notice I said Animals. That's because we're going to create more animals. And now Animal Project is the driver class. It's the class we're using to run this program because we got the main method. So instead, we're going to put this inside of a package called main. And just to demonstrate what I mean by subpackages, main.driver. Now, these packages, like I said, are actual folders. So if I go show in and then System Explorer, and then the window appears on the wrong screen, but here it is. Source main, because we're in because this is the main package. Animals, that's the animal package. It's got the animal.java file, main, and then there's a driver sub package or subfolder inside of it, an animal project. The reason package names have dots is because look up here. When I put the animal project class inside of the main.driver package, it appeared a package declaration, main.driver. Now, why isn't just use slashes? Like normal file paths just use slashes, right? That's because package names are a handy way of referring to another class. So notice how there's no import statements up here. And notice how the animals class is inside of animals package. I can't write this. Animal Joseph equals new animal Joseph. And you know why? Because animal is in a different package. However, you can either import it, and look how when an import happens, it says animals.animal. Just a quick trick, Control-Shift-O imports every class that you need in a program. And I taught this to you before, I'm just refreshing this trick. But anyway, animals.animal, the dot indicates what's inside of the package. So for example, if I created another sub package inside of this one called animals.basic, which I guess the significance of that would be explained later, but anyway, and you can put inside of animals.basic, and notice how the import statement changed to animals.basic.animal. Now, you don't need an import statement actually. Import statements are basically useless. All they do is shorten the name of a class. Animals.basic.animal Joseph equals new animals.basic.animal does the exact same thing as writing out just animal and having an import statement. So import statements are basically lazy. they just allow you a programmer to become lazy because they just shorten the name of a class by removing the extra package headers from it. The dot, remember, the dot can access what's inside of something else. For example, animal dot, and then let's just go to animal age will access the age variable. Of course, age is private, so that's not how exactly it works. However, animals.age will access the age variable. And the dot works with packages. Animals.basic will access the basic package inside of the animals class, and basic.animal access the animal class inside of the basic package. The animals package, not the animals class. And so this is useful because it allows us to organize a code so it's easier to read. And it also allows us to have multiple classes with the same name. Now, I don't know really why you really would want to have multiple classes with the same name. I mean, I guess you want to include a descriptive name that's already shared by another class, you would do that. But I feel like that's not really a great practice unless you have no other choice. But anyway, so this, now that we've organized our classes, we're going to create a new class, and we're going to call that new class flying animal. Now it's a bit of a weird name, but all will be explained. You want descriptive names for classes, and what this is an animal that flies. We're making a class for an animal that flies. It's inside the animals.basic package. I'm going to move it out. You can do that by simply deleting that, and then when a red underline appears, the declared package animal does not match the expected package, just do move flying animal.java to animals. Now notice how this looks a bit funny. Animals, animals.basic, main of our basic is a sub package of animals. So shouldn't it appear inside of animals? So Eclipse does this weird thing called flat package presentation. You can change that by going up to this 3 dots, going to package presentation, and clicking hierarchical. Now the basic package is a sub package and animal inside of basic. So anyway, a flying animal is an animal, right? That means that, oops, wrong one. That a flying animal can die, a flying animal has food points, a flying animal has a name, and it has an age, and it has an X and Y. So why don't we just copy these over? Totally logical thing to do, right? Because, you know, we want our flying animal to have all the traits of animal. Now, I guess we also copy these constructors because, you know, flying animals also can have the same constructors as animals, except, well, maybe we want our flying animal to be a little bit different because flying animals usually have wings, right? So private int wingspan. Now, of course, we have to add that to the constructor. Int wingspan, then this dot wingspan equals wingspan, then string name. I guess we don't have to include another wingspan. We can just define an arbitrary wingspan. 15. All right. I'm not sure what unit that is. Imaginary unit, you know? Actually, that has a mathematical meaning. We should probably not go over that. And back to the animal class. Well, what else? Well, flying animals live. All right. Let's copy this in. All right. This is great. We're making a flying animal. Oh, I guess flying animals age and eat, and they move too, and they move, and and you have to have these getter methods also. Get an increment age. That was kind of a useless method, but you know, it proved a point. But anyway, oh yeah, they also eat. You can kill them. Oh, they can play with other flying animals. Wow. Oh, in fact, like, heck, they could also play with other animals. So we'd have to duplicate these this eat method to involve animals as well, and the play with other animals to involve animals as well. We need a second one. Okay, all right, let's create a new play with other animals method. Now this one will involve animals, and now at this point you're probably wondering, will I always have to copy and paste this much code in Java if I want to just make something which has the additional method of public, void, fly, maybe? Like, this is literally all it'll do, right? Move 0, 1. Just moves up 1, right? That's flying. Maybe an additional system.out.println name is flying. Yeah, this is literally all we want to do with it, but it's an animal and we want to copy all these methods also. Wow, this is really a lot more work than we need. I mean, who wants to copy all this code just to make something that does nothing more than the same exact things as animal, except that it flies? This is stupid. Get rid of it. All right. And I guess we can keep fly for now. And because we're going to go over inheritance. Now, flying animal is an animal. It has the same properties as an animal, and therefore you want to use it with things that an animal has. But in Java, there should be a better way than literally just copy pasting everything from animal and putting it in flying animal. That is why inheritance exists. Inheritance is for when you don't want to copy paste every single line of code from animal and use it in flying animal. And you don't want to have to copy and paste the play with two other animals method to involve a flying animal version and an animal version. So what we're going to do is we're going to make flying animal into an animal, because a flying animal is just another type of animal, except for the additional fact that it flies. Now, public class flying animal extends animal. I just did magic. Wow, crazy. I just made it. Extends. What is this extends? It's like a magic word right here. What does it do? Extends just means that flying animal is an animal. It'll make sure that flying animal has all these fields: is dead, food points, name, age, XY. It'll make sure flying animal has all these methods. And constructors is a bit weird. We'll get to that. But basically what it'll do is turn flying animal into an animal. Now, implicit superconstructor animal parentheses is undefined for default constructor, must define an explicit constructor. Here's the funny thing about inheritance. These private fields, they stay private. Even though flying animal is an animal and it has all of these fields, they're going to stay private. See, the field animal.name is not visible. Now, we could change that, but we're not going to talk about that at this exact moment. So what we're going to do is flying animal, we're going to define the implicit superconstructor. Now, what this means is that since these fields are private, we can't just directly set them, and you can't just leave a field with a blank value. I mean, you can, but Java won't be happy about that. Constructors are meant to initialize fields. That's their entire function. So Java requires you to call a constructor from the flying animal class. Now, why can't you just define your own constructor? Public flying animal, and then string name, Boolean, yada, yada, yada. And then go down here and do this dot name equals name and all that. Well, remember, name is still private. We can't access it from here. And this is going to be a bit complicated, because how are we going to set the fields of the superclass? Well, that's where we get to a special and powerful keyword called super. Super does all the same things as the this keyword. They're both keywords that do the exact same thing, except that super accesses the class right above it in the inheritance hierarchy. So if you do super dot fly, I mean not fly, move, it's going to call the move method from the animal class exactly as defined down here. It's going to call this exact method because super.move calls the class move, and it calls the method move from the animal class. Now, at the moment, this.move and super.move do the exact same thing, but we'll get to that later. Super is useful, however, because see how this constructor is here? This constructor is defined with, can be accessed with the this keyword. Wow, that was very confusing to say. If I wanted to make an animal string name, Boolean is dead, no, not Boolean is dead, int wingspan, and an animal constructor which has an arbitrary wingspan, I can just do this name and then 15, arbitrary wingspan, right? This will access this constructor. See? What if you want to access the constructor from animal though, exactly as it is defined here? Well, you need to, because you need to set the fields, right? That's when you use the super keyword. Now what this does is if I control click this, remember that's a shortcut that takes you to the declaration of a method or a constructor. If I control click it, it'll take me here. Because what I'm doing here is I'm calling a superconstructor. I'm using the superconstructor to initialize all of these fields. Because the fields are private, I can't initialize them to myself. And also, because flying animal is an animal, it needs to initialize itself as an animal. Now, in addition to being an animal, a flying animal is other things. It has a wingspan because it can fly. Private int wingspan. Now, this dot wingspan equals wingspan. That works just like normal because, you know, flying animal wingspan. It's still a field inside of the flying animal class, and you can set it like any other field. Now, this is all well and good. We've created a constructor. The constructor, first of all, it calls a superconstructor. Note that the superconstructor call has to be the first call inside of a subconstructor. And if there was a no arg superconstructor, you know, public animal, this, like that, you wouldn't need a superconstructor call because it would implicitly assume that the superconstructor was a no arg superconstructor. Anyway, back to the constructor. Now, after we call a superconstructor, after all of this runs, we come back down here to setting the wingspan. We take the wingspan here, we put it in here, and we set this field. It's a field, it's just a class. It has a field inside it like any other class. Now after we set the field, notice how we made a method called fly, which I left in there from when I was copy pasting everything. But anyway, fly calls the move method. The move method is defined in the animal class. Right here, public void move int xdiff int ydiff. Now, notice how it shows a red underline under name. That's because the name field, once again, is private. It would be more logical to change this to get name instead, because get name is public. Private means it can only be accessed from the file it was created in. Flying animal is not the file it was created in. Here's where we get to other keywords. So the first thing we need to note is that if we take away the keyword, we get what's known as package visibility. That means that if I were to move the flying animal class into the package basic, now let me just do that right now. I could actually call this or super, or you could do this because they're both the same. This dot is dead because it is not zero, false, because it is in package visibility. You could also do super dot is dead because they're both the same variable. But anyway, or you could take away it entirely. But anyway, package visibility means it's visible from other classes inside of its package. Now, package visibility is, I don't think it's used very often. Oops, okay. Anyway, so I'm just gonna move this out of the basic package. And now you might know why the package is called basic, because the animals class is the basic animal type. But anyway, and of course I do my import statements again. But anyway, package visibility is just removing the prefix and the modifier prefix, and it means that it's visible for everything in the package. Public visibility, you know about that. It means that it's visible for anything in the entire program. Protected visibility is a bit interesting. Protected Boolean is dead. So first thing to note, if I put flying animal back in here again, actually that's a bad idea, never mind, I cannot. I should probably show you with the different class. So anyway, if I go to animals basic and I create a new class called, we'll just name it something arbitrary, demo. And I go here and then I go public demo, and then I do new animal and new animal. Animal one equals new animal, give it a name, animal one, and I do animal one dot is dead. It works because animal has protected visibility. Now you might be thinking, so is that the same thing as package visibility? Like remember, if you take away package visibility, it means it's visible to everything in the package, but not to everything outside of the package. This dot is dead, you can't access the field, etc. Protected visibility looks like the same thing as package visibility. Well, not entirely. Animal.isDead is true. This is package visibility. However, if I go to, if I go to flying animal, which is not in the same package, I can still do this dot is dead because protected visibility allows for visibility in both classes sharing the same package and subclasses. So that's just protected visibility. Now, usually the concept of object is related to the concept of encapsulation, which means making every field private so that it's accessible through the methods of a class. Encapsulation is used so you don't, like, instead of reaching the animal and changing whether it's dead or not, you just use a method in order to change the animal state. So we shouldn't make any fields protected or package visibility because it's not really a good programmer practice. However, we are going to use the animal's normal stuff in order to achieve our methods. So get name, we'll use get name instead of name. I mean, we don't need to use name. Note that if I can now, okay, sorry. Now I'm going to teach you about overriding. Overriding is a special practice because think about a flying animal. Now, when a flying animal moves, this generic move method moves the animal one to the right. However, we would assume that our flying animal usually moves one up, right? Or maybe we can do even better. We can make it move wingspan distance up. Because, you know, land animals move to the right and left. Flying animals, they move up. Now, well, for one thing, we should probably create a getter method for flying animal. You can do control space, type get wingspan. That's not what I'm used to. Get wingspan. But anyway, what we're going to do now is called overriding. Now you can either type out retype out the name of the method, public void move. This works just fine. You can do that, or you can do control space, type out the name of the method, and Eclipse will automatically supply you with the overriding. Now this little thing up here at override, it's not important. You don't need to keep it. You can take it away. It'll function the same. Notice how it says super.move. Now, super.move is going to call this exact method. Super.move will call this exact method. You might have noticed I control clicked on it. It went right here. We don't want that. We don't want it to just call the method that from the animal class. We want to define it as our own. We want to define it as 0 wingspan just to be fun, which means that whenever we call the move method, the flying animal is going to move up wingspan distance. Now, notice our fly method here. We can just use the move method here. We don't need to use the move 0, 1 method. We can just use move. And now we've got a semi-functional flying animal class, which flies. So now, let's make our flying animal fly by using, what's it called? The driver class. Sorry, I did not forget how to call things. I was just, my voice is weird to say. Okay, flying animal Todd, because our flying animal's name is going to be Todd. New flying animal. What did the constructor say again? We can use string name in wingspan, or we can just use string name. Well, all right then. New flying animal. Todd, do you want a wingspan? Let's give him a wingspan of 20. and flying animal Angelina equals new flying animal Angelina. And we're just going to make this a default constructor with the default 15-foot wingspan, or 15 foot, 15 meter, 15 inches. I don't know. And I'm probably going to shorten this to Angie because it'll be easier to say. You don't want too long variable names unless they're specifically described. In any case, now we can do, well, let's see. Todd dot. Now, what does this dot mean? Well, we can call all the methods from animal: age, eats, get age, get it, increments age, food points, get name, get wingspan, get x, get y. Notice like these weird things like get class, get hash code, and equals. We're going to talk about those later, so don't worry about me skipping them. Is dad, kill, live, move, move. All right, well, fly. Todd can fly. Remember, we defined the flying method here. And when we call Todd.fly, note what happens. Todd has moved to 0, 20, and Todd is flying. Because remember, move calls this, and name move to blank. Todd is flying because this line of code says that Todd is flying. Now, if we write Angie.fly, Angie.fly, I can type, I promise. And just to separate them, because I know it's a bit hard to distinguish, I'm just going to put a line of stars. Todd is flying. Todd moved to 0, 20, Todd is flying. Angie moved to 0, 15, Angie's flying. Because remember, when you go to Angie's constructor, we notice it just passes in the value of 15, an arbitrary value for the wingspan. So now this is a flying animal. A flying animal can fly, and if I call, let me just put another line of stars. Oops. Todd, go away brackets. Okay, Todd dot move without the, with the parentheses. Well, then we get Todd moved to 0, 40. Instead of moving to the right and left, so like most animals, which, just move one to the right, Todd moves 40 units up because Todd's move method was overridden in the flying animal class to move differently. And that's overriding. Overriding means replacing a method in the superclass with your own definition for the method so that it can do other things. You can still access the other method with super.move. If we want Todd to move like normal, Todd moved to 220, Todd moved to 240. That's because Todd super.move calls a move to the right method, the right method that moves animal to the right, so 1, 0, then 120 because it moves up here, then it says Todd is flying, because Todd is flying. So super.move just calls the method from the superclass. So it's pretty interesting. And you can't do, like, from the outside, you can't access the superclass. You can't do Todd.super.move if you want to use Todd superclass. Because, the superclass methods are hidden by the subclass methods. They can't simply be accessed. They've been overridden, not hidden, overridden. There's completely, they no longer exist anymore. But right now, we're not gonna do that. We're gonna now move on to a very special concept. Remember about the play with animals method over here? It took in one animal and another animal. And I said that if we're gonna make flying animals, if we're just gonna copy all the code, are we just gonna have to make another play with animals method that takes in another set of animals, namely flying animals? Well, no, we do not. In fact, in flying animal, we can override play with animals. Now, super.play with animals just does move, other one dot move, other two dot move. Well, you know, birds when they play, they fly, or flying animals in this case. We're just using flying animals in place of bird because it's a more descriptive name. So instead of just calling super.play with animals, though you can do that if you want, we're going to redefine this. This dot fly, because this is a flying animal. Other one dot move, because you know, it just moves like normal. Other two dot move. Now, of course, fly and move do more or less the same thing. But anyway, I'm just showing you that you can like override another method. And here we get to an interesting part of Java programming called polymorphism. Now, play with other animals takes in animal parameters. It doesn't take in flying animal parameters. However, after I create a new flying animal called berry equals new flying animal berry. No, not even that. I'm going to make it an animal. So I'm going to import this. Now let's say another set of stars because, you know, berry dot play with two other animals. Well, we don't have any other animals. We just have Todd and Angie, but they're flying animals. However, for all intents and purposes, Todd and Angie are animals. They can take the place of a method parameter which takes in animals because a method parameter takes in animals. You don't need to change Todd and Angie to animals somehow because they're already animals. We can go better. We can also call Todd.play with animals, berry, Angie. Now, what this would do is basically berry.play with animals. Here, move. Other one dot move, other two dot move. So when berry plays with two other animals, it should say berry move to something something. Todd moved to something something. Angie moved to something something. But wait, Todd and Angie's movements are different than Berry's movements. They move up, they fly. So it should say Todd and Angie moved to like 20 or 15 or whatever. I'm just going to remove these statements because I don't want to get rid of our like comprehension by having a bunch of random numbers. So when I call berry.play with animals, play with animals. First it'll call berry.move, which will move berry 1, 0. Then it'll call other1.move. Other1 in this case is Todd. Now Todd's move method is defined in the flying animal class. So Todd is going to move to 0 wingspan. Todd's wingspan is 20, etc. Angie's going to do the same thing except her wingspan is 15. Now remember, in flying animal, we overrode play with other animals. So when we call Todd.play with animals, first thing I was going to say is Todd is moved to 0, 20. Todd is flying. Then it's going to say other1.move. For in Barry's case, it's just going to be 1 to the 1, 0 because Barry just moves 1 to the right. In Andy's case, however, it's going to be 0, 30 because Angie moves up every time she calls the move method. So now let's just experiment with this. Barry moved to 1, 0. Okay, so far so good. Barry moved to 1, 0. Todd moved to 0, 20 because Todd is a flying animal. Todd flies up. Angeline moved to 0, 15. Angeline is a flying animal with a wingspan of 15, so she moves 15 up. Todd moved to 0, 40. Well, this is our overridden move method. Todd moved to 0, 40. Todd is flying because remember, our overridden play with other animals method is this.fly. This.fly includes a line that says blank is flying. So Todd is flying. Barry moved to 2, 0 because Barry just moves 1 to the right, and Angelina moved to 0, 30. Because remember, this calls a flying method on Todd, but it calls a move method for the other animals. Angelina's move method is just move, 0, wingspan. So yeah, this is how the flying animal class can work because the flying animal class is a class for flying animals. And this is a little bit of something known as polymorphism. So that's the other reason you want to do object-oriented programming and inheritance. It's because instead of overloading the play with animals method to take in, oh, play with animals. Well, let's see. Flying animal, other one, and flying animal, other two, and just redefining it over and over, we can just make them extend. And you'll notice, oh, oops. And like this is a bad practice, you'll notice. Like, how many permutations are there? Like, okay, so it looks like when there's two parameters, there are a total of, how many is this? So many, there's a total of 4 permutations. Is that right? Did I do my math wrong? But like obviously this is a bad practice. Oh, and I should change this to fly because we want to make everything fly, right? Yeah, no. That's why we use polymorphism. So we can just input a flying animal here, and they all have a common thing that they can do. But overriding means that each one can do it differently. And that's a part of polymorphism. Now, polymorphism also works for variables. Variables have types. Parameters are just variables, and this works the same way. Animal Todd equals new flying animal. Now, notice if I uncomment these, when I turn Todd into an animal, this means it's still a flying animal. It's just being treated as an animal. So because animals don't have any method which is called fly, Todd can't be considered a flying. Todd is still a flying animal. It can still fly. It just won't be considered something that can fly because it's been cast to animal. Remember casting with integers and doubles? Yeah, that's what happened here. Todd was cast to an animal by being placed in a variable of type animal. Now Todd.fly doesn't exist because animal doesn't have a method called fly. Do you see fly here? No. But flying animal does. However, Todd may be a flying animal, but he's being treated as an animal. And that's the thing about Java variables. Java variables are just boxes with types. If you define a certain type, Java will look inside the box and see that type. It doesn't matter what type is originally in there, it'll look in that box and it'll see that type. Now, of course, you can mess this up. Remember the other kind of casting I told you about with like putting a parentheses and then a type name? Flying animal Todd as flyer equals flying animal Todd. Now, this of course works. Casting works perfectly fine as long as Todd is originally a flying animal. Remember, casting, putting a parentheses around a type name so that it gets converted to that type. Of course, this doesn't actually convert it. This just makes it look like that type. So now, Todd as flyer.fly will work because Todd as flyer considers Todd a flying animal. Of course, so this will work because, works. But you can't do this for everything. Now, flying animal Barry as flyer equals flying animal Barry. This doesn't throw any errors when you try to when you write it. So you know how the Java compiler will automatically dynamically give you errors. That's because until the program runs, it doesn't know what's inside of Barry. It just knows that Barry could be a flying animal. Barry might potentially be a flying animal, but we don't know for sure because we haven't run the program yet. Now, you might be wondering, what's going to happen? We just made the program look at Barry as a flying animal. Well, Barry is an animal. Barry as flyer.fly doesn't make any errors at first because Barry as flyer is being considered a flying animal. Java is taking the box, it's looking inside and is seeing a flying animal. So fly should work, right? But Barry was never defined as a flying animal, and so we are going to get a problem. Class cast exception. Class animals.basic.animal cannot be cast to animals.flying animal. And I'm not sure what this last message is, but that's not important. Class animals are basic that animal cannot be cast to animals that flying animal. And that's of course logical. Barry can't just be cast to a flying animal because Barry was only ever an animal. It was never a flying animal. So casting is a way of switching between types, but be careful. You want to make sure that you're not switching one type into another if it doesn't work that way. Now, there is something known as the Universal Superclass. It's like an ultimate magical entity called object. Now, the thing about object is that you can put anything inside of it. Object ng equals, no, object ng as object equals, not even that, object and obj1 equals ng. Now look, no errors. That's because every single class that exists implicitly extends object. I mean, I could even write extends object here and it wouldn't throw any errors because every class automatically extends object. It's an unnecessary statement because every class, again, extends object. Now, ng as an object doesn't have a lot of methods. It just has these methods: equals, get class, hash code, notify, notify all, toString, wait. That's not funny. Wait. Now, that's the notify all, and the 3 wait methods. Those are methods I'm not going to get into because they're thread programming, and thread programming is beyond the scope of what we're currently learning. Hash code is a bit, I'm not entirely sure I understand it. I just know that it returns an integer, and if 2 objects are equal, then the hash code must produce the same integer result as defined here. But anyway, I don't use that. Now, toString and equals are the methods we're focusing on. Get class returns the class of the object as an object. So there's actually a class called class out there. It's a bit funny to think about, like there's a class representing classes. Yeah. But anyway, we're gonna get into that until a later tutorial. Not at this exact tutorial. But anyway, equals and toString are the 2 methods we want to talk about. Now, how we do that is by overriding those 2 methods. So when we override equals, basically what the equals method does is functions as a double equal sign. The double equal sign basically does it checks if 2 things are exactly the same. System.out.println 2 equals 1. What should this return? Yes, it should return false. This is not return 2 equals 2. It should return true. Now, funny thing, if we do system.out.println, like let's create 2 flying animals called ng2 equals new flying animal Angelina. Now, for all intents and purposes, ng and ng2 are the same exact animal, right? However, ng equals ng2 will not tell you that they are equal. False. And that's because of resource locations. Remember, 2 objects are stored using the resource location. The flying animal variable only contains a resource location. ng and ng2 may have been created in the exact same way, but they still are in different resource locations, and that means that they cannot exist. That means that they cannot be compared to be equal, because when you're comparing them, you're just comparing the resource locations, and the resource locations are not equal. However, ng and obj1 will return equal because they are the exact same object. And that's the equals. However, the idea behind the dot equals method is that ng.equals ng2 should return true. Now it doesn't, because by default, the equals equals method just does the same thing as the double equal sign. See? Return this equals obj. If we go to the actual object class and go to Boolean equals, it'll just tell you, return this equals obj. That's all it does. Nothing else. Just that. Yeah, it's not very useful. And especially if Angie is null, it'll return an error. So why would he want the equal sign? Well, like I said, it's to check if Angie equals Angie 2. So now we're going to override equals equals. Public void, no, public void. Public Boolean equals. Now in this case, because we haven't taught conditions yet, we're not going to get into too much of this. I'm just going to say, you know, the return statement, return this dot name object other, because equals requires the parameter object. This dot name dot equals, now you have to cast it to an animal. Animal other, put a parentheses, because a parentheses indicates that you've successfully cast it like this. Because you have to put a parentheses around the casting, because parentheses are top level, and that means that if I put a dot here, it'll treat it as if it's casted already, because a dot comes before a casting, but a parentheses can indicate otherwise. So this dot name dot equals other dot name. So what this means is that if two animals have the exact same name regardless of their other traits, we're not going to go into other traits. It means that the other animal will have it'll return equal if the two names are equal. Notice how I wrote this dot name dot equal other dot name. That's because strings are objects, and therefore when you just use name equals other dot name, it will return false usually, because two strings may not share the same resource location. So in any case, now we've done this dot name dot equals other name, and that means if I do system dot out dot println Angie dot equals Angie2, it should print out true, because Angie and Angie2 both have the same name. This is irrespective of their wingspan. So if I write like Angelina has 134 wingspan, it'll still say true, because it's just checking the names. Like I said, I don't want to get into too much of complication with Booleans, because that's going to be gone over in the next tutorial. But yeah, that's what the equals equals method does. The equals method does. The toString method is also pretty fun. The toString method just represents a string representation of the object. For example, in the case of an animal, it would probably be name plus at location plus x plus comma plus y plus at age plus age. I think that's all we need. What this does is that if I print out, send the outer println Angie, what this is going to do is it's going to print out Angelina at location 0, 0 at age 0. And if I do Angie, if I do obj1.toString, it's going to return the same name because Angelina has overridden the toString method. Angelina at location 0, 0 at age 0. Yeah, you get the idea. And I can even override toString in the flying animal class. You can do super.toString, which will return this, plus with wingspan. So now we have a better way of comparing when two things are equal. Return this dot toString equals other dot toString. Now Angie dot equals Angie2 should not return true. While if I remove this, it should return true. So Yeah, toString method just returns a visual representation of an object. Equals method checks if two things are equals based on their fields rather than based on their memory locations. And that was fun. Now, just a reasonably quick allocation is that, not allocation, second lesson is that we can make subclasses of subclasses. So you don't have to make flying animal your like last class. You can make chicken next time flying animal. And Java provides this handy little GUI where you can go flying animal and you can just find it. You don't even need to go into the class and write it. This will basically be basically when the class file is created, it's going to automatically put a keyword at the top that says extends flying animal. And if I go here and click constructors from Superclass, ignore inherited abstract methods. We're going to go for that later. If I go here and click constructors from Superclass, then basically what happens here is that it's going to auto-generate the constructors, the super constructors. Watch. Public chicken, string name in wingspan. Super, name, wingspan. Public chicken, string name, super, name. It handily automatically creates a superconstructor. Now, what are the only things that distinguish chickens from most other birds? Well, they can't fly very high, right? Now I can override fly. Return public void fly. Super.fly. Well, no. Are we even going to do move? Well, super.move. No, that does the same thing as fly. Well, I mean, okay, so chickens can't fly. Let's do that then. Chicken get name cannot fly. And I guess chickens are a specific type of flying animal, so their wingspan can be given arbitrarily. And as such, we're just gonna do that. So anyway, chickens cannot fly, so that means we've overridden the fly method. Also, the move method without with parentheses for the flying animal class, all it does is move upward. Well, we don't want that. So instead, what we're going to do is we're going to try to change it back to the move method from the original animal class, right? The move method from the original animal class, 1, 0. How are we going to do that? Super.move. Okay, that's just the original move method. Super.move. No, it doesn't really work. We've run into a bit of a dilemma. And now there are more efficient ways to handle this kind of thing, which will be gone over in later tutorials. But at the moment, this is all I can say. You can't do super.super. You can only access something from the direct superclass right above it. So I'm just going to do move 1, 0. Because after all, that's all we're doing. We're just moving 1, 0. You can do this.move, you can do super.move, and they'll do the exact same thing because the move method is only defined in the animal class. And yeah, essentially, this is now, we've now created a type of chicken. Chicken can take the place of an animal. I can create a new chicken called Berry. Let me Control-Shift-O import. Chicken can take the place of flying animal. Flying animal, Berry as flying equals flying animal, Berry. Chicken can take the place of object. Object obt1 equals Berry. And that works because chicken is an object, chicken is a flying animal, and chicken is an animal. Like, you know, I can do whatever I want. I can now if I do Berry dot fly and Berry dot move, or rather Berry as flying dot fly. Let's see what happens. So Berry is flying dot fly. Chicken Berry cannot fly. Okay, that's what we wanted. We overrode fly here so that it can't fly. Berry.move. Berry moved to 1, 0, because, you know, when you go to the chicken class, it just moves 1, 0. Berry.play with other animals. Well, first of all, the flying animal method, play with other animals, calls this.fly. Berry cannot fly, so he doesn't fly, unfortunately. Todd moved to 0, 20. Angelina moved to 0, 15 in Berry.play with other animals. Now, Todd.play with other animals, Todd does fly because Todd is able to fly, and Berry moved to 2, 0, and Angelina moved to 3, 0, 30. And this is inheritance. Inheritance is a pretty complex subject, so I'm going to quickly recap. Now, we can use methods from a superclass from a subclass. We can also override those methods so that when you try to call them, they will always run whatever you overrode them as. If you redefine a method, that's its definition. Even if you cast the class to another class, to the superclass, it'll still use that definition. Now, variables that are private are not accessible from subclasses, but variables that are protected are accessible from subclasses as well as from other classes in the same package. Variables without a descriptor at all are just accessible from the same package, and of course, public variables are accessible from the same package. You can give anything. You can create two things with the same name as long if you create something with the same name in a superclass that has the same name as something in a subclass, you can distinguish using the super and this keyword. For example, super name, this name. In chicken, for example, super name. You can call the superclass constructor with super, and you call this constructor with this if you wanted to. I mean, bad idea. Don't do that. But anyway, you can go here. You can call super dot something as shown here, super dot toString, and it'll call the method from the superclass. However, if you try to call super dot something, it won't work. You can't access a twice above superclass from a subclass. An animal, a class which extends another class has something called polymorphism. So animal berry is a chicken. Because a chicken is an animal, it can be considered an animal in an animal-shaped variable. It will still be a chicken, it'll just be considered an animal. You can cast things back and forth using the cast notation, which is parentheses. Cast notation is top-level notation. If I do flying animal berry, I don't know. If I do, int y equals double y equals double 2 plus 3, cast notation is what's going to happen first. However, dots come before casts. So if I do berry.age, berry dot get, if I wanted to system out of println berry dot get name, but I also want to cast berry to an animal, it will try to cast what you get from get name, because because casting is top level notation, but dot is top level above casting. Now, these are two important concepts: polymorphism and inheritance. You do polymorphism to shorten code. You do inheritance also to shorten code. Polymorphism is useful because, like, you can make sure you don't have to rewrite all the fields from animal again in flying animal, and then once again in chicken, and you don't have to rewrite all the methods with taking animals as parameters again, like animal other one, animal other two, and rewrite flying animal other one, flying animal other two, and chicken other one, chicken other two. You don't have to do that because you can just use inheritance. Now, this was my inheritance tutorial. If you didn't like this video, tell me what I can work on. If you did like this video, compliments are appreciated, but you can just like and subscribe instead. And if you have suggestions on how to improve the quality of this video, again, constructive criticism is good. Thanks for listening. I will see you in the next video, and goodbye.